All right, welcome back everybody. We have 3.3 headers and multi-file programming. Now you can see we have a lot of things going on in this. I'm starting to include these little, kind of buzzwords of things that's going to be learned in this lesson. So we have headers, the preprocessor, header guards. You're going to learn about macros, multi-file programs, and multi-file programs with classes. Now, if it's your first time here or you're one of my students, if you could please subscribe. Really trying to get my ideas out there and see, am I teaching this the best way that I can be teaching this? All right, what are you going to learn in this lesson? All right, and this is the real breakdown here of how things are going to go. So you're going to learn why we need multiple files. And this is a very important reason, okay? You're going to learn all about what the preprocessor does and all the directives you can use with the preprocessor, and that's going to have some live code. You're going to learn how to put those commands in header files and, how that works with the preprocessor, obviously with a live example. And then first, we are going to do a multi-file program without classes. I think it's important to see it that way because that's kind of how you would have saw it in C. And then we're going to do a multi-file program with classes, okay? And you're going to see that they're similar, but they're also very, very different. And then you'll get an assignment, something that you can use to kind of practice. You will need the quick code from the previous lesson in 3.2 because we're continuing on with that student class. Okay, let's dive into it. The problem, why we need multi-files, okay? So this, we're actually going to need to take a little tour. We're going to go on to GitHub here in a second, and we're going to inspect the Python, what's really called CPython, which is the Python interpreter. Now, just kind of heads up, one file to read them all is just a really, really bad idea. We're gonna prove that in a second, okay? Now, Python is a programming language, but it has what's called an interpreter that reads each code a line at a time and interprets it into like a runnable bytecode. And that's a very, very oversimplification. But that program is not really written in Python, although there's some parts that are written in Python. It is actually written in the C programming language because C is a very, very fast language. Okay, and so you're going to see probably some similar code. All right, let's stop talking. Let's dive into it. Okay, so here we are at GitHub, github.com, and if you have never been to GitHub before, I highly recommend checking it out. Okay, you can see all sorts of open source code, and you really get to see how people design huge projects. And so one of the things we're going to learn, we're going to check out is the CPython, right, which we just talked about. And you can see it's completely open source. You can go in and you can dive in to every single file that they have. And so I'm going to, first let's zoom in a little bit here. I'm going to go to Python, right? And you can see, for starters, look at all of these files already. So the .c is a C programming file. Okay, we've only opened up one folder. And look at all these files already, okay? Now and then there's another folder in here. Let's jump back, okay? And then let's look at modules. First off, we have tons of folders, and look at all of these C files, okay? All of these C files, a lot, and ton. Let's go back one more time. We're gonna open up one of these in a second, okay? And let's jump back to Python, and let's just pick one. Let's pick compile.c, okay? Now we have some comments at the top here. Look at all these includes. We got some macros here, okay? But I'm just gonna start scrolling. And I'm gonna keep scrolling. And I'm gonna keep scrolling. In fact, it's gonna take a little too long to scroll. We're gonna go down this way. Let's just keep going and going. We're at that couple thousand lines here. Couple thousand lines here. And we're coming down to a single file with over 6,000 lines of code, okay? Now, you may be going, well, they could have split this up, and they could, but it was all related to compiling a file. Now, if we really think about this, look at how many there are just here alone. It's about 100 files here. They're not all 6,000. They could be more. They could be less. Then we have modules. We have Mac-specific stuff. We have PC-specific files. We have an entire library of code. And look at these. All these are folders here, which all have their own set of files in them. And then all these PY files, which are, this would be pure Python aspect of the language. And that's a ton. If you try to put everything in one file for a real legitimate program, you are not going to make it very far. You need multiple files, but we have to kind of work with how do we get the compile to recognize those multiple files. So let's jump back here to kind of our presentation, and let's first talk about what the preprocessor is. So the preprocessor is a program that handles preprocessor directives and modifies your source code, okay? Now, you may not realize this, but if you're using something like REPL.it, or you're watching me compile the program with G++, all of this is happening when I do that every single time. Okay, and we're going to walk through this. So the first step here is the preprocessor is going to take your source file, so that .cpp file, and evaluate all the preprocessor directives by sending it to the preprocessor. Okay, and what's going to appear out of that is a modified .cpp file, only doing that processor. And this step is not compilation. This step is simply doing just the preprocessor directives, okay? And this is the only, C and C++ are the only language that has a preprocessor, okay? Then that new modified code is fed to the compiler, which outputs another file, a .s file, and then that is fed to the assembler, which outputs a .o file, which is assembly, and then that is linked by the linker with other .o files. So this could happen multiple. These steps can happen for every single file that you have, and then the linker links them together, okay? And that, and also it links them with, the standard library file. So not just your stuff, but the things that you need from the standard library that you've included and stuff like that, okay? Now, I put here you've been using this the whole time because you have. Here's your first example of a preprocessor directive. Include IO stream, okay? What is important about this is that the preprocessor, when it sees this line, it's going to go find this IO stream file and it's going to drop that whole header into your program, okay, and modify it that way, all right, so that you have all the stuff that you need from this, okay? So you've been using them already, okay, but we're going to expand upon them today. So the first big additions we have is what's called macros, which is our define and our undefined directives, okay? And then we also, of course, have our source file inclusion, which you have already done a ton of times, as you can see here, okay? But define, it really is kind of simple. Creates a definition, and undefined will undefine that definition. And now look at kind of how you do this. This is crucial here. You write define, and then we use all caps. And so this is basically making a variable here. So I've made a word max, and I've set it equal to 1,000. Notice how there's no equal sign, though. Notice how there's no semicolon at the end, okay? You simply just write define, the name of it, and then you give it a value. Now, define is not only used for variables. We can use it for functions. We can use it for tons and tons of things. Even stuff called loop unrolling, which is insane. But we can what's going to happen here is the preprocessor, when it gets this program, for starters, it's going to look at this include. It's going to include that file. And then it's going to sit there and go, every time I see this word max, I'm going to replace it with 1,000. So in our program here, that modified program, so this step right here, this modified source.ppp, it's going to actually have 1,000 there. It's going to change that. And what's cool about this is let's say you don't like writing endl. You just want to put maybe the letter E. You just hate writing endl, right? Or maybe a capital E. You could put a capital E here, endl, and it's going to swap it out, okay? There's actually some people that have used this to use the preprocessor so they can write in a different language, and the preprocessor is going to change it to C++. It's really cool stuff. Okay, let's get this working now. Okay, so let's jump to some code real quick and see what this is like before we get into header files. All right, so here we have a file, right? It's kind of all the standard stuff. We do have a preprocessor directive here, but we're going to add that max here. So we're going to go with the hashtag first, define. We're going to give it a name, max. and we're going to put 1000. No semicolon, no nothing. Yes, this should be capitalized. Okay, so that way you can easily recognize what's a preprocessor directive instead of just a regular variable. And we're going to go C out, put the word max, and then our end L here. Okay. Now, when I go compile this, we have G++, main.cpp. Everything works good. I run the output, 1000 prints out. Okay. And that was max, that was 1000. But let me show you this. Okay. So if, I know most of you who are working with me here are doing REPL, but if you are in the compiler and you go G++ dash E, capital E, and you say main.cpp. So dash E is going to give you, the modified code after the preprocessor, okay? But I want to save this into an output file. I'm going to call it preproc.cpp, okay? So I run that. There's no issues, right? We don't see anything happen, but there should now be a file, look at this, called preproc. And when I open it, look at this new file. And you can see a preview over here on the right. All that you're seeing right here, all of this up top, is that first include. It just included the entire header file for IO stream, which you can see there's a lot of template classes, okay? All of that just got included into your file, okay? And then all the way at the very bottom, look, all the way at the very bottom is our file. And notice how there is no, look at this, there is no macros here define, and there is no word max. It put the 1000 in its place, okay? Now there is a danger because you could see that all this is being included, right, in our file here. This is where that term at the very beginning, header guards, come into place. We want to make sure that this only gets included once. Even if we have multiple files that are including, IO stream, we only really want it to end up in our final product once, or else all of this is going to just get really, really, really repetitive. Okay, so that's kind of our first example. Let's jump back to our slides. Okay, so there's a lot more to the preprocessor. Okay, and so we have all these conditional preprocessors, and they're all close to self-explanatory. Okay, so for starters, this gives us an if, right? An if statement. This will end an if statement. So if you notice, there's no semicolons, right? So there's no braces to tell you when an if statement starts and finishes. And this is actually something that used to be in all languages. Before the C programming language, you used to have to tell them with an if statement when it started and have to say something like end if. And this was even for like for loops, like end for. So this is, it used to be pretty common, all right? We have our same thing for the else, and then we have what's called an elif, which is an else if, okay? So these three, the if, the else, and the else if, are all similar and work the same way, but you do have to put an end if at the very end. So you can kind of see at the bottom, it gets blocked there when I go down there with the pointer. At the very end, we put that end if, so we know that that chain ends. Now these two up at the top are different, and these are actually going to be really important for what's called header guards. I'm going to show you that in a second. I'm pretty sure on the next slide, but you can kind of see this reads pretty normal, right? Like let's define a max, call it 1000. And this is really a pointless chain of if statements, but look, if max is less than 1000, undefine it. So it's grayed out because it won't run. And if we undefine something, we can then are able to redefine it. So we can't define it again until we undefine it. Or if it is greater than 1000, undefine it. Or else just undefine it and let's redefine it as 10, and then we have the end if down there, okay? So, this kind of macros or conditional preprocessors, it's pretty common, but you're really not going to see us need it yet. And, here's a better example of what you could do. You could be like, if the operating system is a Mac, let's define a file that's Mac specific. Else if it's a Windows computer, let's define a Windows specific file that does the same thing, but is compiled properly and written properly for an operating system, okay? So that you can use the same method names in your actual program, and then it'll swap in the correct framework, okay? Now, header files are really the place that you want to put all this stuff. The only thing that should really make it into your CPP files is source inclusion. All this macros, even function definitions, can go what's called a header file. So header file is a file ending in .h or .hpp. And so if it's .h, it's for a C file. If it's .hpp, it's for a C++ file, okay? That contains function declarations and macro definitions, okay? That's our macros. These are our function definitions, okay? And header files are included in source files. So, if you started to notice when we learned functions, we started putting all sorts of functions up top, right? Function declarations. We can just put these all in a header file now and then just define them in the actual file so we don't have to worry about them, okay? Now a couple more things. For starters, when you include your own header file, you have to surround that name by quotes instead of by these angle brackets. And I'm going to show you what that looks like, okay? And the most important thing is you need a header guard when you do this in your header file. And what I mean is, look at this. If not defined, and we give it the name, right? And we did mystuff_hpp, so that means this file is called mystuff.hpp. You have to do that underscore. You have to all cap it here, even if the file is not. Then you need to define it and define this and make these function declarations, and then we end that if statement that started up here at the top. This ensures, as you saw, that the preprocessor included all that header file into our program. It ensures that if you include this mystuff.hpp in multiple files, that we only need one, right? That it's not going to be included 15 times because that would just bloat our code and bloat our compilation and bloat our runtime. Okay. Now there are more directives. Okay, there's a ton of them. These are just some of them, not all of them. So we have line control, we have error directives, we have a thing called a pragma directive, which actually simplifies that header guard, where you can just write pragma once, but we're not going to do that one today. And then we even have predefined macro names, like this would print out the current line of code that you're running. And this is 2 underscores at the beginning and 2 at the end. And if you do that with a file, you can see out the name of the file in your program. You can get the date, the time really easily. And then you can even get the C++ standard that it was compiled in. And there are more of these, okay? And then lastly, your define can be used, and I think I already said this, can be used for more than just swapping variables and numbers. You can use it for loop unrolling and even to create functions in the macros, okay? All right, so let's jump back to our code. And let's see what this would look like if we all put it in a header file. So you can see we have 2 files open now. We have a main.cpp and a main.hpp, okay? Now, this naming scheme is important. You should always, whatever header file matches a certain CPP file, they should have the same name so the compiler can easily find them, okay? So what we're first going to put in here is our header guard. So if, and the N is for not. So if not defined, and we do it in all caps, main_hpp, okay? So if that's not defined, so if it's not defined already in our code, hasn't been included somewhere else, we need to define, all caps, main_hpp, hpp, okay? And then, of course, within that, we need all of our stuff. So I'm going to take this macros right here. I'm going to take it out of the CPP file, and I'm going to put it here. Okay, and then we actually also had some functions. So let's define some function declarations. And we're not defining them. We just put the declarations here. So I'm going to go void, and let's do the announce. And it's going to take a string message. But you got to be very careful here. I have to remember the namespace here. Okay, as a general rule of thumb, you should not do a using namespace in a header file, because if you do that, you force everybody else to use it. So if you remember, string came from the standard namespace, okay, using that scope resolution operator. And so we need to include that here, okay? And I'm going to put message. And then I'm just going to end it, okay? Just like that, all right? I don't need to define it here. I'm just going to end it. And then at the very end, you need to remember to include your end if that ends this original if statement. This all should be in here. If this is not defined, do all of this. Okay, now, all right, notice how we left max here. This is totally fine now because it's going to be over here. But at this point, we haven't actually told our CPP file to include main.hpp. So we're going to go back to include, okay? And this time, instead of these angle brackets, I'm putting quotes. I'm putting main.hpp, no semicolon. The angle brackets are for things from the standard library. The quotes are for header files, these are for header files that come with the language, essentially, in the compiler. These are the ones that you make, are in quotes. And it tells the compiler to look in different places. This tells the compiler, look in the same directory as this file, because that's where this one should be, okay? And this tells the compiler, look in the standard library source files, okay? All right, let's make sure they're both saved, because I have a dot over here, so I haven't saved this, okay? And now I'm gonna run this code, and let's define this. Let's define announce, okay? So I'm gonna go over here in the CPP file, I'm gonna go void announce, okay? And now I am using the standard namespace here. So I don't have to worry about that there. Although I guess I'm sending arguments, so it doesn't matter. Let's go hello world. Oops. Oh, what am I doing? Okay, now I still need to make this a parameter. Okay, so I'm gonna go string message, all right? And then make this bigger, okay? Let's just see out that message, okay? Just like that. And then we can call it right in here after max. Let's call announce and send it hello world, okay? Now this is very different from before because normally we had a definition down here that meant that we had to put a definition up here, or excuse me, getting those words mixed up. This is the definition, which meant that we would have had to put the declaration up top. But now it's just in the header file. It kind of keeps things organized, all right? Let's give this a run or compile, so G++, main.cpp. I don't need to pass it the HPP file. And let's give it a run and look, boom, 1000 print and hello world print, okay? Because all this got put in this place right here, okay? By the preprocessor before compilation, okay? And this, you know, it kind of keeps things clean. Like I know where to look for my macros, right? It's over here. I know where to look for my function, declarations. They're over here. And I don't have to bloat my CPP file, okay? So I think, well, and let me show you, you know, I did show you those kind of other directives. It was kind of light, all right? But just so you kind of have that proof, like, look, if I go file like this, it should print out main.cpp, okay? So let's watch here, let's compile, no errors, run, and look, main.cpp printed out. And so you can do date, time, you can do a lot of stuff here with these pre-built in macros, okay? All right, let's jump back to our PowerPoint here. So, okay, multi-file program, all right? And this, you know, it looked like we just did a multi-file program, right? We had a .hpp, we had a main, but that's not really a multi-file program. We don't want to convolute our main with a bunch of other, you know, functions, okay? So what we can do here is we can do a mystuff.hpp and a mystuff.cpp, and that's where we put the actual function definitions, okay? And so that in main, none of those are in there, okay? And so it's very similar to kind of what we just did, but now again, those definitions are going to be in different places, okay? Now all the declarations and macros should be in the HPP file like we did, and all the definitions should be in the CPP file with the same name. And when you include the .hpp file in main.cpp, the compiler will know to look for the matching .cpp file. So that sounds confusing, right? Here's how this works, okay? We know these two are linked, kind of, right? But notice how inside mystuff.cpp, I have to put the include. And notice how in main CPP, I have to put the include twice. This is why, because I mean, the compiler needs to know that both of these have access, right? And then this is why we include those header guards. We don't want this actually stuffed in twice, okay? We want it actually in our final program just once, okay? Now, if you were compiling with G++ or Clang C++, you need to compile both of these files. If you're using something that just has a run button, like REPL or an actual IDE, It's going to make sure that it takes care of the multiple file compilation for you, but I'll show you how to do it in the command line. And then good practice to call the file with the main method as main.cpp so you can easily find it. Now it's more important than ever. Okay, if your main method is in a file, you should call it main.cpp unless you have a reason not to call it main. Okay, all right, let's make an actual one with multiple files. Okay, so we got several files here. We have a myfile.cpp, we have a myfile.hpp, and we have our main file over here. Okay, now, and I said to call it myfile instead of my stuff. All right, but the first thing we need to do is we need to check, make sure we put that header guard. So if not defined, so if end def, right? If not defined, and we got to pass the name. So if myfile_hpp is not defined, then we need to define it. myfile_hpp. Okay, and then let's scroll down here. Let's put our end if. Okay, then we can include some other macros. So I'm going to go define. I'm going to go name this time, and I'm going to use a string. I'm going to go for abacus. Okay, because that is also possible. And then let's put some function declarations. So void. Let's just do some different stuff. So add with maybe an int x and an int y, right? And then what else could we possibly do? Let's do another add that returns it this time. Now let's not get too crazy. Let's just do an overloaded add. Now let's just do a subtract, but we'll do it with doubles. Okay, and then that way, we're seeing some different data types here, right? So this is possible with the string. Okay. And then we have our two definitions here. All right, so I'm going to save this, okay? Now in myfile.cpp, you need to treat this like a regular file, okay? If you need to do some printing out in this file, you still need to include the IO stream, okay? So the compiler knows that this needs it, okay? And then I need to include, and this time in brackets, or this time in quotes, I need to include myfile.hpp. Okay, and if I want to use the standard namespace, using namespace std also, I have to do that again. Okay, now here in myfile.cpp, I'm just going to use this file to define those function declarations, the add and subtract. So I'm going to go void add. It takes an int x and an int y, and I'm simply just going to go cout x plus y, and then put an end L. Okay. And then I'm going to go void, and I'm going to go subtract, or it's a double x, double y. And I'm just going to, again, print out the subtraction of the two. Okay. Now this doesn't run anything, right? If you compile and run, this doesn't do anything here. Okay. Because all we did was create these functions. None of them are being called though, right? So we need to now go, so let me move this over here. We need to now go to our main method, our main file that has our main method. And you can see we've already included it, the myfile.hpp. We're using the standard namespace. Instead of max, we have, let's go to our HPP file here. We have name. Okay. And then we have our add and subtract. We can call those, right? So I'm going to call add. I'm going to send it a 5 and a 2. So that should print out 7. I'm going to call subtract. I'm going to send it, again, a 5 and a 2.5. So that should print out 2.5. So I'm going to save that. And now I need to compile this, but I have to also compile myfile.cpp. And remember, this is getting included into the file, so it doesn't need to be compiled like separately. Okay. So now if you look at the bottom, I'm going G++, and I'm not only going to send main.cpp, but I'm going to send myfile.cpp. And I'm going to use the -o tag and say that I want to just call this program. Okay. So this is the call to the compiler. I'm sending it the main.cpp, the myfile.cpp, and this is a tag to let them know I want to send some additional stuff. And this is specifically sending a name instead of the a.out. It'll be called program. Okay. I press enter. Everything looks good. And instead of doing a.out now, I can do program. Okay. And just like what we want, we get for abacus printing out. Good. We got our 7 and our 2.5. Now let's Let's see if this shows you anything interesting. Yeah, so if you type in cat and a file name, you can see what that compiled version looks like that you just ran. And this is it. It's mostly compressed though, so it's hard to tell what's actually going on, okay? All right, so this is multi-file, you guys. It's not too crazy, but it's kind of an orchestration to get everything to work together. But notice how, I can create files that do a specific task. So if you think about IOStream, yes, this includes a header file, but there's a real file, an iostream.cpp. And that is going to have everything you need to have these actual methods to see out, okay? That's going to actually print out the things that we need it to print out, okay? And the cin. And so we can create files that are related to a certain thing and include those functions so that we can just include that file whenever we need them, okay? All right, we got one more thing to look at, and it's going to be doing this with classes though, and it adds a little bit of complexity there. All right, you can see that this is looking very similar to the previous slide without classes. Okay, we still have 3 different files. And I decided to put this in between classes part 2 because doing it this way adds a lot, like all these header file information. There's a lot of information, and I don't want to spend I want to spend classes part 2 on class design. And not necessarily on how to get it into a separate file. So we're going to do it here, okay? Now you're seeing we have a myclass.hpp file, okay? And in the HPP file, it's just like normal. You have your header guard, and then you have the class declaration. So I have the class triangle, I have the public specifier, I put my variables there. I'm not setting them equal to anything, just putting them there. And then you can see I have the declaration for what the constructor looks like. It takes the 3 sides. And then I have the declaration for a perimeter method that's going to print out the perimeter of the triangle. Notice how, again, there's no values being saved here. Okay, now let's go over here to the right, the myclass.cpp. All right, notice how there is no class like here, like you don't see this class. All we're doing is picking and choosing the part that we want to define. And in order to do that, we need the scope resolution operator, the double colon, okay, which you've seen us use with the namespace. This helps it find it. Look, we want something from the triangle class, and we want the actual triangle function constructor, and it took these parameters, and now look, we set A equal to A1, B equal to B1, C equal to C1, which are the incoming arguments, right? Notice how in this file, .cpp, the myclass.cpp, we never defined A, B, and C because they were defined here. And if you remember, this include here puts all of this above it. Okay, so it's there, all right? Now next, we wanted to actually define the perimeter method. Now this is where you got to get very specific. Notice how the return type was first, double, and then where we do the name, we say, hey, we want the perimeter from the triangle class, okay? So we put the class name, the scope resolution operator, and then the function name, and then we can define it. Return, well, to sum up the sides were A, B, and C, because those were the class members right here, and so that would return the perimeter, the sum of all 3 sides, okay? And so when we fast forward to our main file down here, okay, you can see we created the triangle try, and we send it 1, 2, and 3 for the sides. Not saying that those could actually give you a triangle, because I doubt that actually could. I don't think that they're long enough, but, sue me. Yeah, they're definitely not long enough. And then we're printing out the perimeter method there. Okay, so again, we're keeping the file with the main method nice and clean, okay? The only real difference here is this scope resolution, okay? You can't just put the word triangle and put the word perimeter. You have to do the scope resolution so it knows where to find it, okay? Now, in the past, we used that scope resolution for namespace. It's like the same thing. And now we're going to use it to match functions to its classes, okay? Outside of that, everything else is the same. So let's do an actual example. All right, so as promised, we're going to do this again, but we are going to do it with a class. And so again, we have to include our header guard. So, if not define my class underscore HPP, define my class underscore HPP. Okay, and then I'm going to go scroll down and put my end if. Okay, so here we're going to put the actual class. Okay, and we could put a lot of classes. We have more than one here. It doesn't have to just be one. And instead of doing the rectangle or the triangle, rectable, we're going to do the rectangle. Okay, so a rectangle could have two different sides, right? So two need to be the same. So we're going to do, our public specifier, and we'll just do, length and width we normally call them, right? So we'll go double length and double width because opposite sides are the same, right? And now we can actually really easily do an area. And instead of just printing out the area here, generally what you want to do is return what the value is. So the value can be used somewhere. So because we're using doubles, our return type should be double. And so double area, and it doesn't need to take anything, okay? And it doesn't need to do anything here because we're just saying what's in the class. And then we're going to go double perimeter, and that's the same thing, okay? Boom, you're done making the header file, okay? So I'm going to save that, and now I'm going to go to the .cpp, all right? And I'm going to actually define this. Now, in my rectangle class here, I actually don't need any input or output. I'm not going to print anything out. I'm just going to return the values. So the only thing I need to include is the myclass.hpp file. And I could, I don't even think I need the standard namespace, honestly. And so now I'm going to use, let's go ahead and define these things. Actually, I am missing something crucial here. Okay, that's why I was like kind of slowing down there. I was like, well, what am I missing here? I'm missing the constructor. So we need the constructor, has the same name, and it should take we'll call it L1 for length 1, and, we'll just call it L and W. L and W, okay? And now I really just have to define these things, give them, definitions, right? So we'll go and we'll use the name of the class, so rectangle, the scope resolution operator, and then the name of the constructor, and we know it takes a double L and a double W, okay? But now I need to actually save those. So I'm going to save them to the class member variables at length and width. So length equals L, and you put a semicolon there, and width equals W, okay? And then I'm going to do the same thing with the other one. So double the return types first, use the name of the class, the scope resolution operator, and then I use the word area. Now area is simple, right? The area of a rectangle is length times width. So I'm going to return the length times the width. Okay. And then for perimeter, it's also kind of simple, right? I need the name, here we go, class, perimeter, and I'm going to return, and we have to do the sum of it, right? So there's two lengths and two widths. So I'm going to go 2 times length, like that. And let's just use a 2.0 here so it stays as a double, plus 2.0 times width. And I could have just wrote length plus width plus width, but that's not that cool, right? And so now I've given all of these their definitions, okay? All right, let's go to, this needs to be saved. All right, let's go to main CPP. All right, I need to include that header file again. All right, so myclass.hpp. And then down here, I can just start creating objects. I can go, I want a rectangle. I'm going to call it rect1. And I'm going to give it a value. Let's say it's got a length of 3 and a width of 5. Okay, now let's create a second one. Rectangle, call it rect2, and we'll give it 10 and 15. All right, in fact, let's throw this one with some double values. So 10.5, let's go just 15.1, okay? And then I can just start calling them, right? So I could print out here, C out, and go and call the area method. So let's make this easier. Let's look at the actual, what they look like while we're calling them. So I know this returns the value. So I can call it in a C out, or I could save it in a variable, all right? But we're just gonna print it out. So I'm gonna say, rect1 area, like that. I'm going to go rect1 dot area. Okay. Let's scoot this over. Okay. And I'm just going to copy and paste this and do it for rect2. So rect2 area, and then I got to go and make sure I call the rect2 instead of the rect1. All right. And I'm going to do this for perimeter. I'm going to go rect1 perimeter and call the rect1 perimeter. And then I'll copy and paste that and do it for the second one. All right, so copy, put a 2 here, put a 2 here. All right, so I'm going to save this. I need to compile, let's just clear that. I need to compile both of these. So I have to go main.cpp and my class.cpp, and then I'll tell it that I want to just call a program. Okay, and it'll, save over all that stuff. Okay, we got some errors here. New types. Oh, I know what I did. Oh, look at this. Simple error. No semicolon. All right, let's see. There could be more errors, but that was the only one. So just kind of a quick little lesson here on the compiler. Right, this first error here, look at this, expected semicolon after class definition. Right, that's the error that I kind of quickly figured out. The rest of these didn't, they were completely wrong. This first error here tripped up a bunch of other errors, tripped up the compiler. So when you're trying to debug, sometimes don't start at the bottom here. Now that's the first one you see. Start at the top, fix just that one, rerun it, and maybe that was the only issue. Okay. All right, so now we should be able to run our program. So let me call it, and boom. Area of the first one's 15, area of the second one is 158.55, good. The perimeter of the first one is 16, that's solid, and the perimeter of the second one is 51.2, and it's all working, okay? Now, yes, all of this could have been in one file, but remember back to the beginning, real programs have thousands of files, okay? And if you had them all in one, it would have millions of lines of code in a single file. Imagine trying to find an error, right? So I hope this helps you guys. Let's get you to your quick code. All right, so there is not going to be an example for this because this one, it would be very difficult to do an example for. And this is a simple quick code because it was a lot, and I just want you to get your previous quick code from 3.2 into separate files. So take your quick code from 3.2 and separate the student class into its own header and CPP file. So all the declarations should be in the header file, and all of the, the definitions, which is the implementation, should be in the CPP file. And then you need to make sure that it runs. So you need to test the methods that you have in the CPP file to make sure everything is working, and do not forget your header guards. If you forget them, your program will still work. However, it's not going to, how do I say this? It's going to be bloated. And if you keep that practice going forward, you're going to have some pretty big issues. Okay. All right, everyone. Thanks for watching. Appreciate it. Support the channel, subscribe, please. Give it a like, give it a comment. Really trying again to spread my ideas. Is this the best way to teach this? Am I teaching things incorrectly? I want to know this. I want global feedback. So appreciate your time, everyone. Have a great time.